So number 28, we're looking at solving this equation. And a couple ways we can do this. The easiest one, though, would probably be using our LCD method. However, we have to be very careful because remember, whenever we want to solve these things, we always have restrictions, and we can never divide by 0. So our first step is to find our restrictions. So our restrictions, if we look at here, we have an x on the bottom. So what value of x can I not have is 5. So we say x cannot be 5 because 5 minus 5 is 0. Then we can go and solve this, and if we find our LCD, we notice that the only thing in our LCD is going to be the x minus 5. So that left side already has the LCD. The right side is missing an LCD. So let's multiply the numerator and denominator by x minus 5. So on the left side I have x squared minus 25 over LCD. The right side is going to be x plus 5 times the missing factor of x minus 5. And that gives us our LCD over here. And we cancel these out, and let's see what happens. So here, if I keep that, it's going to be x squared minus 25. And the right side, if I FOIL that out, I'm going to get x squared minus 5x plus 5x. So that's going to cancel out. And then minus 25. And if I try to move these x squareds together, I get minus x squared. And I end up with negative 25 equals negative 25. And my x squareds cancel out everywhere. So remember, whenever I end up with all my variables canceling out, there's two possibilities. There's either no solution or infinitely many solutions. And how can we tell the difference is if this last part is actually true. Is it's the same on both sides, and it is. So our answer is infinitely many solutions, or always true basically. However, our problem is we do have a restriction, so it is always true, except since we can never have x is negative 5, we just say it's always true, except when x is 5. So that's this one right here, D.